Hello and welcome to this module on Conveyance Technologies. My name is Philippe Raymond. I'm an environmental engineer working at Airvac Sandec on sanitation planning in international development projects. I will be presenting the different conveyance and treatment technologies. In the last modules, Lukas Ulrich introduced you to the user interface and collection and storage technologies. Now the question is, what happens when a pit is full? How do we transport wastewater or sludge out of a neighborhood? Well, there are two categories of conveyance or transport systems. On the one side, the sewage systems relying on pipe networks, and on the other side, the non-sewage systems relying on different kinds of container-based solutions, about which we will focus in this module. The different sewage systems will be presented in the next module. We have three learning goals for this module. First, to get to know the different ways to transport sanitation products. Secondly, to get an integrated view of manual and motorized emptying. And finally, to understand the pros and cons of the different technologies. Let's start. We will take a look at the different ways to transport sanitation products, focusing first on manual ways and then on motorized ways. Many development projects focus only on drinking water supply or the provision of latrines. However, in both cases, building new infrastructure also implies new sanitation products which need to be transported and properly treated. These products, which we call here output products, can be, for example, black water and grey water, sludge, urine, dried feces, or pit humus, according to the technologies that are implemented. We will focus now on the transport of products from on-site sanitation systems and, more specifically, the conveyance of sludge, or if you prefer, fecal sludge or septage. When a pit is full, people have the choice between two options. Either they let the pit overflow, which is both a nuisance and health hazard for the neighborhood, or they call manual and motorized service providers to empty their pit. The most efficient and hygienic way in such a case is the use of pumping trucks. However, in low-income contexts, the use of trucks is often not possible. The main reasons are either that there is no access for trucks, that the sludge is too thick to be pumped, or that households cannot afford the often costly service. Thus, people often resort to manual emptiers. Unfortunately, most of the time, manual emptying looks like this: a hard work in very unhygienic conditions, provoking hostility from neighbors. Manual emptiers face very harsh conditions and, at the same time, lack recognition for their work. This situation can be improved with proper equipment and technologies. Human-powered emptying of pits, vaults, and tanks can be done in two ways, either with buckets and shovels or using a portable, manually operated pump specially designed for sludge, such as the Galper, the Rammer, or the Mappet. Manual sludge pumps are relatively new inventions and are still being optimized. Sludge hand pumps, here the Galper, work on the same concept as water hand pumps. As the operator pushes and pulls the handle, the sludge is pumped up and discharged through the spout. It can then be collected in barrels, bags, or carts and removed in a quite hygienic way. Next to that, it is important also to ensure that workers are adequately protected with gloves, boots, face mask, and overall. It is important to mention that proper equipment and organization help the manual emptiers to gain recognition and acceptance. Sanitation programs should strive to legitimize the work of the laborers and create the right enabling environment by providing permits and licenses, as well as helping to legalize the practice. Let's now look at motorized emptying. Motorized emptying refers to vehicles equipped with a motorized pump and a storage tank, namely pumping trucks or vacuum trucks. Generally, the storage capacity of a vacuum truck is between 3 and 12 cubic meters. Pumping trucks come in all sizes and shapes, as shown here on these four pictures. They can be locally manufactured, which ensures that maintenance skills and spare parts are available. A drawback, however, may be a limited efficiency. Smaller vehicles have also been developed to access areas with narrow pathways where normal tracks cannot access. Let's look now at the pros and the cons of motorized and manual emptying. The main advantages of motorized emptying are that it is fast and efficient and minimizes health risks. However, it has high capital costs as well as operation and maintenance costs. These costs are often passed on to the customer, who sometimes cannot afford them. Besides, the trucks cannot pump thin sludge, garbage in pits may block the hose, and the pumps usually only suck to a depth of 2 to 3 meters. Trucks may also have difficulties with spatial access, and spare parts may not always be available. The main advantages of manual emptying are low operation and maintenance costs, the possibility to access every pit, and the availability of maintenance skills and spare parts. However, it has a limited efficiency and is a time-consuming activity, and it implies health hazards when not done properly. As said before, it is tough work. Besides, it requires a disposal point nearby within 500 meters. In both cases, proper disposal of the sludge is a challenge. Distance has a cost, but not only. Traffic jams, police checkpoints, bad state of the road may add to the costs and turn into hindrances for sludge conveyance to treatment plants. Emptying service providers aim to reduce distance and time for each trip, save fuel, protect their track, and minimize the problems with the population. All these aspects need to be taken into account when selecting options and designing a fecal sludge management scheme. Distance is a critical issue. If the distance from the collection points to the treatment plant is too long, there is a possibility of building transfer stations. Transfer stations can be underground holding tanks where manual emptiers or small-scale motorized service providers bring their sludge. The sludge is then further conveyed by vacuum trucks. Another option is a sewer discharge station, where sludge is directly discharged into an existing main sewer line. In that case, it is important to manage discharges with care in order not to overload an existing wastewater treatment plant. Transfer stations can be a useful interface between informal settlements where vacuum trucks cannot access and formal settlements where municipal or private motorized service providers are active. They have to be carefully located and well maintained to minimize odors and problems to nearby residents. To sum up, we see that container-based conveyance is much more a management and institutional issue than a technical problem. It needs to be addressed when building any type of latrines and collection and storage system. Most cities in low-income countries rely mainly on on-site sanitation systems. Container-based conveyance is not an exception. It is rather a norm. So far, it remains mainly a private sector business, in which, unfortunately, most sludge ends up untreated in the environment. Proper management schemes and sustainable financial arrangements need to be put in place for the sludge to be treated, for the service providers to be recognized and legalized, and to reduce the health hazards, both for the workers and for the neighboring population. Above all, we have to remember that conveyance to proper disposal points has a cost. The critical aspect is thus to estimate this cost and see how it can be shared between the different sanitation stakeholders. To learn more about fecal sludge management, about manual and motorized emptying, and how to plan a sustainable fecal sludge management scheme, we strongly recommend the recently published EAVAC Sandec FSM book that you can download for free at the link shown below. In the next section, I will be presenting the sewer-based conveyance technologies. See you then!